Okay, we're going to look at some of the sample problems from your 2.5 homework. So if you'll look with me, these are some printed off from your math program, so yours may have different values but the same ideas. So we're talking about the equation of a line. We basically have three equations of a line. In 2.5 we have standard form, ax plus by equals c. So when it asks us to put the final answer in standard form, it means no fractions, sort of the capital A, B, C infer no fractions. So we have to clear our fractions and then put the x value in front, the y value second, and then the constant on the end. The second equation of the line is y equals mx plus b form. That's slope-intercept form. Anytime a linear equation is solved for y, we see the slope in front of the x variable and the y-intercept on the end. We use that a lot for graphing. You saw that in 2.4 more. But this section dwells on this formula the most of the lesson. And this is the point-slope form of a line. So it's exactly what we see on number 1. We have a point given and a slope. So we can directly plug it into that equation, and it says answered in standard form. And so there's different iterations of that same idea of using mainly this equation. So here's where we plug in our point, the x sub 1, y sub 1, and here's where we plug in our slope. Sometimes they flat out tell you the slope, like here and here. Let's see, the first three. And then we get to some other where you have to work for your own slope, find the slope to put it in. Alright, so let's get started. So this first one, we'll use this equation, y minus the y coordinate is 1, m is given to be negative 2, and then x minus the x coordinate is 3. I mean, basically once you do that, you've put it in standard form. I mean, you put it in the slope-intercept form, it's in the equation, but we haven't cleaned it up to standard form, I should say. So we need to distribute. There is no fractions on this where the slope wasn't a fraction. We won't have to deal with that. Then put the x in the front. 2x becomes positive 2x, right? Then the y is brought down, and then the constants took to the other side for a total of 7, and that would be our answer in standard form for number 1. All right, number 2. Number 2, we're going to do the exact same thing, only we'll have this fraction to deal with. So y minus the y coordinate is negative, so y minus negative makes it plus. And then the slope is given 2/15. X, again, minus a negative makes that plus. Now this time, to clear the fraction, we were going to times through by the LCD, which is the 15 you see here. So 15, multiply that to each side. We're allowed to do that. It keeps the balance. On this side, it needs distributed to 15y plus 15 times 6. Sorry, 15 times 6 is 90. Sorry about that. And then on the other side, the reason we times by 15 is it will cancel out that fraction. So we'll just be distributing the 2, making 2x plus 12. Now, in standard form, the x needs to be in the front, so it makes it minus 2x. Bring down the 15y that's on the left, take that plus 90 to the end. 12 minus 90, let's see, I think that's negative 78. Now that answer is probably fine in standard form, but this book seems to change all the front negative signs. If the x value has a negative coefficient, it changes all the signs. So we times through by -1, basically changing every sign. Gives us an equivalent form that's in standard form that the computer likes. So we'll type in our 2x minus 15y. See, it knew it needed to have the minus on the 15 when we changed all the signs, and then equals 78. So you will need to watch that. If you have a coefficient that's negative on the x, times everything by -1. That means both sides by -1, and that basically just means every sign is opposite before you put it in the final answer. Okay, I'm going to skip number 3 since it's very similar and go down to number 4. Number 4 says write the equation that's through this point and has an undefined slope. So that's a special case. Undefined slopes are x equals constants. And then 0 slopes are y equals a constant. So those are our special case lines that we learned in the last section. So since this says undefined, that means x equals whatever x always is. And in this case, we have a point to tell us what the x value would be, -5. You could graph that to see at negative 5, 13, there's a point, and if you draw straight up and down undefined slope, it's going to be at x equals negative 5 all up and down that line. So the special case. On number 5, we have to find our own slope. So they don't just give you a slope, they give you 2 points, which is all we need to figure out our slope. So to figure out your own slope, it is equal to the subtraction of the y's over the subtraction of the x's. And this just formula kind of tells you need to subtract in the same order. If you go 5 minus 4, you need to consider 2 minus negative 1. But you can also subtract in the other order, because who's to say which one's the first point and the second point, really? Anyway, it doesn't matter about that. The order doesn't matter, it just needs to be consistent. You need to subtract in the same direction, the y's and the x's. Alright, so the subtraction of 5, that y minus that y, and then in the same order with the x's, this x minus this x would make that plus, so we get 1/3. So the slope is 1/3. Now you might wonder which point to use, and it just doesn't matter. As maybe surprising as that seems, it comes out the same in standard form, and that's why we have a standard form, because it will be the same answer in the final form regardless of which point you pick from that line. Let's see, I think I'll take the first point. So we will have, let me find a little space to work this down here. Here's your equation, that point slope equation that we use a lot in this section. And again, I'm using the point negative 1, 4, and the slope we found was 1/3. So y minus 4 equals 1/3. X minus negative 1 makes it plus 1. And then if you have a fraction, you have to times through and clear the fraction. So it times both sides by the 3, and that makes 3y minus 12. Over here the 3's cancel, so I'm just distributing the 1x plus 1. Then final form puts the x to the front, so there's that negative x that we talked about earlier. Then the 3y brought down, the minus 12 to the other side, 1 and 12 is 13. So standard form needs the coefficient of x to be positive, so I'll change that to positive 1x minus 3y and negative 13. That's my final answer. X minus 3y equals negative 13 there. Okay, number 6, we're going to graph on this one. It says find the slope and y-intercept and graph that. This one is already solved for y, so that's kind of helpful already, solved for y. If not, you have to do that on your own. Then the slope is 4, or 4, well, let's put that over 1. When you don't have it as a fraction, it's assumed to be over 1. And then the y-intercept is negative 6. So what is the slope? 4, or 4 over 1. And what is the y-intercept? It says type it as an ordered pair. So we need to say when x is 0, y is negative 6. That's how we'd write it as a point. Then over here, when we sketch that graph, we start at the y-intercept of negative 6, and then rising 4. Let's see, 1, 2, 3, 4, running 1. You can do that multiple times if you like, because it's always up 4 over 1. From any point to point, that slope stays the same, that ratio. All right, number 7. So number 7, we're going to do that again, but this time it does not solve for y, so we have to do that on our own. So we want to get y alone by throwing the x across the line. So negative y equals negative 5x plus 6. Then divide out the negative 1 that's in front of y. Y equals 5x minus 6. So that's your slope, that's your intercept. So 5, or 5 over 1, and the y-intercept's same as the last problem, isn't it? So we start at the y-intercept of negative 6, and then rise 5, run 1. Very similar to the last one, but we had to solve it for y first on our own. Now this time when I solve for y, my y-intercept is at 0. I don't have a constant on the end of this, so it's understood to be 0. So your slope is negative 5/4, and your y-intercept, which is the origin, is 0, 0. So we start at the origin. Now this time we've got a negative sign. You know, negative slopes always go this way. It's a decreasing function. So I'm going to go down 5 and then right by 4. You can also consider this 5 over negative 4. The negative can go on top or bottom, just don't double use it. Let's see what that looks like. What if I went up 5 and back 4? Same line. You see how that works either way. Just don't double use that negative, but know there's a negative sign that needs to be in use. All right, then we get to our questions about parallel and perpendicular lines. So what we need here is to figure out the slope of the line we're parallel to. In this example, when we're parallel to a line, that means we have the same slope as that line. So we need to figure out what the slope of this line is, like we were doing above. Solve it for y by throwing the x across the line. Really doesn't matter about the 7. We're just really interested in the slope. And you're able to find out there's a negative 1/4 there in front of the x. So the slope of this line that I'm parallel to is negative 1/4. And so that means my line will have the same slope because we're parallel and go through this point. So it's really just the same thing over and over. You'll get tired of this, right? And then use that little equation. Plug in your point and your slope. So y minus, my y point is 4, slope is negative 1/4, and my x point is negative 1, which will make that a plus 1. Again, with the fraction. Now, I know that this can be confusing. I do get questions about this one because the first question is put it in slope-intercept form. I think it's easier to go ahead and get the second answer first, clear your fractions, and then go back and get that answer. So that's what I recommend. I think it's just easier than trying to distribute that fraction. You can do that, but I think it gets a little tough. Then you have to add 4 to the fraction. So fine if you want to do that, but I recommend timesing by the 4 and not having to work with fractions at all. So when I times by 4, it makes 4y minus 16. And the reason we times by 4 is it cancels out that denominator. I have a negative 1 to distribute, so negative 1x and minus 1. Then standard form, we'll put the 1 in the front, the 4x is next, and then throw the 16 over makes a total of 15. So that's going to be answer B, actually. So I wish they would put those in the other order for you, but that's answer B, so hang on to that. For answer A, I would use this form of the equation and solve it in slope-intercept form, which means now solve it for y. Now, I know you might be saying, hey, I just did some of that up here, but that was for a different reason. That was so we could find out this parallel slope. That is not the equation we have now. So you go from this equation that we just found and then rearrange it in slope-intercept form. So 4y equals negative 1x plus 15, then divide by 4, and there we are in slope-intercept form. Negative 1/4 x and 15/4 would be your answer to A, the slope-intercept. Now, it does have the same slope as that other line, but yeah, that's what we were supposed to do, find a line parallel to it. It has the same slope, but notice that intercept on the other one was 7/4, so we have a different parallel line. If we graph those, the visual would help kind of see that. Okay, then you have another parallel example on 10, and then lastly, on number 11, to get practice with perpendicular lines. So we'll go through this process again. It's the same question, but this time our slope is perpendicular to this line. So remember, we're trying to use this equation again, our point slope equation. We have a point 1, 6 to plug in. And then, let me turn this around. That's distracting there, isn't it? That's still distracting. Move my junk off my office desk. So we need to know what is the slope of this line to put in for the slope here, m. And we're perpendicular this time. So I still have to solve it for y to find the slope of this line, which makes negative 3x plus 1 divided by 7. So the slope of this other line that we're perpendicular to is negative 3/7. Now, when your equation is perpendicular to, that means we're negative reciprocals of this. They're obviously going opposite ways if they're going to meet at a 90-degree angle. So one's positive, one's negative, and then the other deal is it's reciprocal. So our slope that we're looking for, the slope of our line, is positive 7/3. Now we plug all that in, and then we do exactly what we just did on the last equation. We times through by 3 to clear our fraction. And then we rearrange these equations. The 3's cancel. Put the x in the front. the constants in the back. We don't like that negative on our x, so let's times through by a negative and change all of our signs. That's answer B. That's standard form. Keep in mind. For slope-intercept form, I'm going to use this equation and rearrange it, throw the x back over. I know it seems like we're just all over the place here, but this is how you do this, how I recommend doing it. Then divide out the negative 3. And then y equals, that's negative 7/3. The negative can be on the outside, the upside, any place as long as you put the negative on the fraction. And then negative over negative makes that positive 11/3. And that would be your answer to A part. The slope-intercept form is y equals negative 7/3 x plus 11/3. And then for B part is this standard form, 7x minus 3y equals negative 11. All right, lots of practice with manipulating the algebra, rearranging. I hope that helps.